Up until this point, we've been talking about what happens when chords and secants and tangents intersect, what happens to the angles and the arcs that are formed by those lines and segments. For this next part of the unit, we're going to be talking about what actually happens to the segments themselves. How do they intersect, and how do they break each other into pieces? The actual chords and pieces that intersect with the sides of a circle. So we're going to talk about today what happens when chords intersect, what happens to the chords themselves when they intersect. So we have chord AB and chord CD, and when they intersect, what happens is they break into pieces where EA times EB, so EA and EB multiplied together equals EC and ED. So each side, the pieces multiplied, the pieces of each chord multiplied together equals the pieces of the other chord. So we look at how we set this up. So I have 23 and 15, and then I have X and 23. So you would say 23 times 15 is equal to 23 times X. Well, we could go through the math, but it's very easy to see with this one in particular that X has to be 15. There's no sense in even doing any of the math since everything is identical except for that X is 15. So let's look at one that we need to look a little bit more at. You look at your pieces, 6 and X. So I would say 6 times X, and then 3 times 4 equals 3 times 4. So let's do some simplifying. 6 times X is 6X. 3 times 4 is 12. And that means that X is 2. So we could find out, and this would literally happen if you were to lay string out, cross it, you would literally see that the products of the pieces are equal to each other. So 3 times 4 is equal to 6 times 2. That works. Of course, we can't stay that easy. We got to bring in some algebra. So I have 6 times X plus 4. Be careful. Don't write this. It's not 6 times X plus 4. Don't write like that. It's 6 times X plus 4 plus, equals, and I know the X is going to be there, so I'm going to write the 12 first. 12 times X. And if you want, it may be a good idea, and I probably should have done it all along, is to write it in parentheses, because as we substitute in, it's better to put it in parentheses. That way we don't make mistakes with parentheses problems like this. But you don't have to, but just be careful when you have binomials that you need to multiply together. So we distribute our 6. So I have 6 times X plus 24 is equal to 12X. And then combine your like terms and solve. Subtract 6X from both sides. And you get that X is equal to 4. So that means the other length, this is 4. And the other length of that is 8. Well, 4 times 12 and 6 times 8 are both 48. They equal each other. The products equal each other. So find ML and find JK. So again, we have our pieces. Our chords are intersecting. Notice we're not talking about arcs. We're not talking about angles. There's no degree measures. These would all be measures in inches, feet, centimeters, meters, something like that. So we're going to take X plus 3. Right here, X plus 3, and we're going to multiply that by X plus 1. Again, when you have binomials, always use parentheses. And then we have X plus 5 and X, and it doesn't matter, but I'm going to put the X back in front so that it looks like distribution like we're used to. So we need to now distribute in order to solve for X. So we need to distribute on our left-hand side, so we get first times first. Outer times outer, and inner times inner. So you get 1X and plus 3X is 4X. And then 3 times 1 is 3. And then distribute this X. X times X is X squared plus 5X. Now the good news is that we were scared for a minute there that we thought it was going to be a factoring problem, but there's an X squared on both sides. And so those are going to end up canceling each other out. I'm going to subtract 4X from both sides, and I get that X is equal to 3. That was nice. So then ML is that entire length. So ML, when I substitute it in, it's 3 plus 3, which is 6, and 3 plus 1, which is 4. So ML is 10. And then you use the same 3. So JN is 3 plus 5, which is 8, and X is 3. And so JK is 11. Notice that the lines themselves are not the same length. That's not the point. It's that when you multiply them together, that they are equal. So 6 times 4 is 24, 8 times 3 is 24. It's the products that are the same, not the actual lengths of the lines. So when you are looking at the chords and you want to know how long the pieces are, when you have intersecting chords, the product of the pieces of one chord are equal